Now let's continue about the difference between conductors and insulators. So again guys, what is meant by the word conductor? Any materials that easily conducts heat and electricity. So there is a high conducting capacity, especially for wiring materials. That is why it's the reason that our wiring component, when it comes to material installation for electrical equipment, it is made of copper. Most of our wiring component. Next, what is meant by the word insulator? An insulator, it is an electrical material in which it has a very low conducting capacity or very poor and low conducting capacity. So this one is safe. So this kind of material helps to coat next layer to the copper wire component. Okay? So let's find out. Identify conductors and insulators in this picture. Okay. So which one do you think is a conductor? Can you point? Okay, so let's find out. Okay, the metal nose pliers and the copper wire. Right? So where is there an insulator? Okay, so the cover of the nose pliers and the rubber coating that helps you to protect against electrocution. Then gloves is also part of insulator. So let's now focus about unit and symbol for electrical circuit. So a system of conductors and components forming a complete path for current to travel. Okay, take note of this. Properties of an electrical circuit includes one, what is this? Voltage. Next, current. And the other one is resistance. Right? So these are the main component units that usually part of the properties of electrical circuit. Now let's find out what is its particular unit. What is the unit of voltage? Okay, volts. V-O-L-T-S. The unit of voltage is volt. Okay, so that's why guys, most of our batteries, there is a certain number of voltage between positive and negative terminal, and of course, the loading capacity of how many number of volts or voltage component is present in this battery. So we can use any voltage amount. It depends on what unit or devices that we're going to use. And we need to use a battery. Next one, what is the unit of current? Amps or ampere. The unit of current is amps or ampere. Next one, resistance. Okay. So what is the unit of resistance? Ohms. Ohms. So this is the unit of resistance. Okay. So this one, we can use symbol after the unit or as indicator of unit. Instead of using volts, we can use a symbol of V. Then amps, a symbol of A. Then ohms, okay, so this one, the lambda alpha, okay, component. Let's proceed. Now let's find out what is current. How can we emphasize the word current? Okay? Remember that current comes into two different terms. Current, it talks about time, right? In English expression. So, literal or basic expression, when we talk about current, means to say the current, the present one. But in scientific theory and application, current is present, no? And being used as a term for electricity. No? Don't be confused between the two terms of current. Current in English, okay, and the other form of current when it comes to electricity. Do you understand? So, current is a flow of electric charge. This measured in amperes. So the basic measurement when it comes to current is amperes. So, how can we determine the current? Okay? This is our tank, for example. So we will try to relate this with the water tank. This is just only the basic relativity of situation. Since we're talking about the real electrical energy or the source of electricity. But this one, we can relate in other situation. So this is your tank. Okay? Serve as a battery. So our battery, for example, so this battery, okay, relates to the amount of water inside the tank. And this one is a wiring component. A pipe represents as a wiring component. Right? So, then the faucet, okay, this will serve as a switch on and off. When to use it, every time you're using it, when you stop using it. Right? So therefore, continue. When the faucet is switched off, is there any flow of current? Is there any flow of current? How can we determine between this one, the tank battery, the pipe wiring, and then the presence of water, then every time we switch on and off? When the faucet is off, is there any flow of current? Yes or no? What do you think? Is there any flow of current? If it's off, okay, no current, right? Because it's closed. So, of course, no current is present. When the faucet is on, is there any flow of current? Yes or no? When the faucet is on, is there any flow of current? Yes or no? Based on this diagram, where we are basing about water tank, as another base of example. Yes or no? Of course, yes. There is a water coming out. That's the same thing with electricity. So, therefore, when the switch is off, there is no current. Alright? Okay, Juan Cao, can you switch off the light? Okay, so when we switch off the light, alright, there is no current. This is the indicator. Okay, again, Juan Cao, you kindly switch on the light. Okay, so now this is the indicator that there is a presence of current. Okay, and we can now see the lights. So, when the switch is off, therefore, there is no current. When the switch is on, there is current. Okay? So in this circuit, we have current flow. Conventional current assumes the current flow out of the positive side of the battery through the circuit and back to the negative side of the battery. This was established in conventional electricity, okay? But it always starts, no? So for example, here, in conventional current, so this diagram, okay? Electrical circuit diagram, as you can see, right? With positive and negative terminal. What is this? This indicates with battery or charges. Okay? The load capacity. No? And then where it starts. So normally in conventional current, it starts with positive to negative terminal. The connection always starts in positive, okay, then going to negative terminal. This is for conventional electric current. However, electron flow is what actually we used, no? Especially for electrical engineers or students can. No? This happens in which electrons flow out of the negative side of the battery through the circuit and back to the positive side of the battery. So this is now what happened. Okay? It's reverse. Okay? When it comes to electron flow and conventional current. So in conventional current, I repeat, from positive to negative. Do you understand? However, in electron flow, the actual application starts from negative to positive. Okay? So that's the way how we determine the diagram of electric or electron flow in this circuit. Right? Now let's continue. So, engineering versus science. The directions that the current flows does not affect what the current is doing. Thus, it doesn't make any difference when conventional is used as long as you are consistent. So, for student application, it might be different. For engineering application, it might be different. So, both conventional current and electron flow are used in general for science subject area of discipline. We use electron flow for student project. Okay, circuit diagram application. Okay, if you are still a student. But in real life situation, okay, electricians or electrical experts, okay, might have another diagram to show. No? It depends on the area or places, no? In various households in your community. So, whereas the engineering discipline use conventional current because it involves with complex situations and different materials. So, since then, engineering course will be used conventional current, but not using the electron flow diagram. Okay? But electron flow diagram emphasizing with students' applications.